Okay, so let's go back to this thing here. We're trying to find the standard deviation for this data. X stands for the data 28, 14, 8, 21, and 2. These are the data set we have given, and we're going to use this steps to find the standard deviation. Good. So the first step, find the deviation of each data from the mean. In other words, subtract the mean from the data value. So first of all, to find the standard deviation, you need to find the mean, average. So let's find out the average. What is the mean of this data? The mean of this data is, just add this data, 28 plus 14 plus 8 plus 21 plus 2, divide by total number of data, 1, 2, 3, 4, 5. And what is the mean? 14.6. Don't round it unless they ask you to round it. Don't round anything. To compute the standard deviation, you need everything as it is. Make sense? So that's the mean. If you use X to represent the data, this is the trend. This is how we represent the mean. X bar. X bar stands for mean for that data, average for that data you have given. Clear? Okay. So now we're done with the step 1. We found the average, but still we need to find the difference between average and then data. So we make one table here. We write down the X here and difference between X and X bar. So X is, I'm just copying this data, which is 28, 14, 8, 21, and 2. I'm going to find the difference between this data and X bar. Don't forget that X bar is 14.6, right? So 28 minus 14.6 is, what is that? It's 13.4. Am I right? X means 28, X bar means 14.6. So 28 minus 14.6 is 13.4. And you are going to repeat the same thing for each of them. 14 minus 14.6 is, second, negative 0.6 or 0.6. 8 minus 14.6 is negative, is that 6.6? Okay. 21 minus 14.6, second, it should be 0.4, so that would be 15, so 6.4, right? 2 minus 14.6, negative 12.6. You can also write down this data in order, like from lower to the higher or higher to the lower, but it doesn't matter because you're not trying to find the median. Make sense? So that is our step 1 from here. Find the deviation of each data from the mean. In other words, subtract the mean from the data. That's what we did. Subtract the mean from the data. Are you with me? Okay. What is the next step? Now the next step is square each deviation. The meaning is whatever you got here in the second column, just square that. Meaning is, notation wise, you are squaring the value you have on this column. So what is the 13.4 square? Find out 13.4 square. So you can just 13.4 and then square it. It's 117. It's 179.56, right? Hey, here is the thing. Don't round it. Because if you round it at this point, then your final answer would be completely different. The standard deviation, if you are trying to find the standard deviation, don't round your answer until the final point. Make sense? So that's 179.56. Let's do the same thing. 0.6 square is, 0.6 square is 0.36. And then square of the negative number is always positive, so you don't have to worry about that negative number. That's 0.36. 6.6 square is, you can always go from fraction to the decimal. It's a 43.56. 6.4 square is 40.96. 12.6 square is 158.76. So these are the square of your deviation. Deviation means x minus x bar. The square of that is, you just have to find out the square of each of these values. And while doing that, don't round your answer. Good? That's your step 3. Sorry, step 2. That's your step 2. Square is deviation. That's what we did. Okay. Are you with me? Okay, next step is add the square deviation. You have to add this square deviation. So you just have to add this column. 158.76 is already here, so I'm not going to enter it again. Plus 40.96 plus 43.56. How do you go back? 43.56 plus 0.36 plus 179.56. So if you add them all, it will be 423.2. Make sense? Yes? Okay, sometime we might use this notation for addition, this notation. This is called sigma notation. It means add the value you have given. So for this one, I can also write sigma x minus x bar squared. That means I'm adding that column of x minus x bar squared. Make sense? That is our step 3. If you check your note, you can see that. Add the square deviation. Say again. Sigma means it's just a notation for that thing, the addition thing. Let's go to the next step. The next step is, after adding, divide by n, which means the total number of data value. If the data represents the whole population, divide by n minus 1 if the data represent a sample. So in this problem, if you check the problem itself, it says a sample was done. A sample was done. So that means this is for sample. This is the sample. Make sense? So for this particular problem, what is the value of n? N means total number of data. 1, 2, 3, 4, 5. So the value of n is 5. But if it's sample, you have to divide by n minus 1, which is 4. So the next step is, to find the standard deviation, you divide this 423.2 by n minus 1, which is 4 in this case because it's a sample. So what is 423.2 divided by 4? It's a 105.8. Good? No. If you check your notes, it says after adding the square deviation, you divide by n minus 1 if you are playing with the sample. And n is total number of data. There are 5 datas, so 5 minus 1 is 4. That's why you divide by 4. And that is the number you get. Are we done? So still we have to do something else, and that is the last thing here. Compute the square root of the result. So after finding this 105.8, that's not your final answer. You have to find the square root of this number, which is the square root you can find from this calculator. Here is the square root sign. Square root of your answer, and that is 10.2859. Sometime this is your final answer. This is the standard deviation. Sometime they ask you to round it to the 1 decimal place, sometime 2 decimal place. So just follow the instruction and give the answer. But that's your standard deviation. So the meaning of standard deviation for this problem is, look at here. For this problem, the data is, this is your data, 28, 14, 8, 21, 2. The average is 14.6. In average, most of this data are 10.2859 unit far from the average. That is the meaning of standard deviation. Make sense? Okay, if it makes sense, then let's do the problem 2 together, and that's where you can check the things, you know, how much you